it's a little bit of review here at the end, but it's nice to see one more time. So linear velocity and angular velocity, you can actually use one of them to find the other, which is kind of strange, but it's true. So a point rotating with uniform circular motion. Okay, what's an example of this? A wheel going around. I think we talked about a bug earlier in the notes. That bug on the wheel, that would be a good example. A paddle boat, the wheel that keeps it going. A Ferris wheel, if you've ever been to a fair or someplace, or like Navy Pier, where that'd be another example that you could look at this way, and we're going to actually discuss those tomorrow. But for now, we'll keep life straight. This is, I know it says know this is on your help sheet. So we'll just stick that we need to know it that way. So find the linear velocity, no radians. If the radius is 2 inches and the angular velocity is 5 radians per second. So, all right. So if I just straight follow that, I got 2 inches times, bless you, 5 radians per second. This is the only thing that can catch us on this. 10 inches per second. Lose the radians. Okay? The only reason we're using this is because we've got that per second that we're using as a label. Like we've got written over there. Feet per second, miles per hour, whatever they are. No radians when we're looking linear. However, if we're looking for angular velocity, let's manipulate a little bit. I'm not going to put this in the same equation. If I want to know what linear is, I want to solve for omega. So if I want to solve for omega, I take linear velocity divided by the radius. Now, could I stick them just both in there and do algebra? I could. I just like being able to plug and go. So I'm like, all right. So we've got linear velocity, 8 centimeters per second. And we're dividing by r, which is 3 centimeters. If you want to skip this step because you know what's coming, that's fine. But if you're not sure, I think this is a good method to go. Do not try to do this vertically. That, pain in the butt. So, all right. Flip this. 1 over 3 centimeters. Now, be careful. Okay, those cancel. So I end up with 8 over 3. And you're like, okay, so seconds is on the bottom. Okay, per second. It's angular velocity. No pi anywhere to be seen. I just have to remind myself, especially since I see no other measurement, all I see is the seconds down here. Well, angular velocity is not just seconds. It's got to be some measurement of an angle. That's where the radian part comes in.
So do you not have to divide it out to get the decimal?
It depends on what's asked for. If I didn't put in there exact answer versus decimal, and you did 8 divided by 3, and you put like 2.7 or 2.67 radians per second, that's fine. Okay. Yeah, whenever you don't see a very specific go decimal, go this, you can go back and forth. Just be aware though, like if you saw an answer that was written like this and you have the decimal, just check quick and see if they're the same, and that'll work fine. So one last one. See, shortest notes ever. This is nice. Find linear velocity. Okay, linear velocity. If the radius is 1 and the point rotates at 20 revolutions per minute. Quick review to yesterday, right here. If you're given revolutions per minute, you do need to multiply to get it into a radian form by 2 pi. So 40 pi radians per minute, okay, is going to be your angular velocity. Okay, so that's the one thing we're going to have to make changes on. Otherwise, the formula has not changed. If I'm looking for linear, nothing to mess with. My radius, 1 foot, get your label in there, Hardy, times, bless you, 40 pi radians per minute. So here comes the ever important label. Linear velocity, 1 times 40 pi would be 40 pi. I'll show the decimal on this one too when we get there. 40 pi feet per minute. That just got us to where it's angular, but again, we're looking for linear. Don't put the rad in there. The pi is fine. No rad. 40 pi. So if we went decimally, 125.7 feet per minute. And again, if I don't mention decimal versus exact, you pick which route you want to go. I'll take either. Do I need to change minutes to seconds? On this one, I don't, since it was talking minutes from the start and I didn't see a second somewhere else. Like this all stays in here. If I'd have had that change like we saw in some yesterday where like I saw minutes in one area like with this and then like my velocity or something was in seconds, then I'd make the difference. But yeah, otherwise we can just leave it in the format that it's in. So as we said yesterday, more time today to play since you didn't get as much time yesterday. So reminder, we're still on 3 and 4, and I'll try and get there. There we go. So whatever you weren't working on yesterday, work on that today. Because again, we need to reinforce this stuff. If you get done and you're like, I'm bored, instead of looking at random stuff, take a flip to the back of your packet. Again, it's a unit test review. It's going to be chunky. It's going to take more than just like half a class period to look through. So please start checking that out a little bit. Yes, there will be a work day in class next week to work on it, ask questions, things like that, and I'll have the video posted later today. But please, please, please don't wait until the last minute to get that situated. Like